Humans just flew around the moon for the first time in 53 years, and that was only the beginning. NASA's real goal isn't a flyby, it's a permanent base on the lunar surface, and they've already spent $93 billion working toward it. So what exactly is the plan? Why has it taken this long? And what happens next? On April 1st, 2026, NASA's Artemis 2 mission launched, the first crewed flight beyond low Earth orbit since Apollo 17 in 1972. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, flew around the moon on a 10-day journey that captivated the world. On April 6th, the crew reached a maximum distance of 252,756 miles from Earth, breaking the record for the farthest any human being has ever traveled from our planet. They flew over the moon's far side, photographed ancient craters and lava fields, and watched the Earth rise above the lunar horizon in real time. They splashed down in the Pacific Ocean off the coast of California on April 10, 2026, completing a nearly 10-day journey that made them the first humans to travel to the moon and back in more than half a century. It was historic. But NASA isn't celebrating a victory lap. Artemis 2 was a test flight, a proof of concept. The real mission, the one this entire $93 billion program has been building toward, is still ahead, and it's far more ambitious than simply going back. The goal is to stay. People often ask why we're going back to the moon when we already went 50 years ago. The answer is that what Apollo did and what Artemis is trying to do are completely different things. Unlike the short visits of the Apollo program, Artemis's goal is to facilitate long-term stays on the moon, to construct a lunar outpost, conduct scientific exploration of the lunar South Pole, and help NASA prepare for future missions to Mars. Apollo planted flags. Artemis wants to build infrastructure. There is a profound difference between the two. And there is something else driving the urgency, a space race that most people aren't talking about. China has an aggressive lunar program and is accelerating its timeline. NASA Administrator Jared Isaacman has stated plainly that the crewed lunar landing missions are slated for 2028 and that the goal is critical to beating China to the surface. They might be early, and recent history says we might be late, Isaacman said. But this time, the goal is not flags and footprints. This time, the goal is to stay. This is not just a science project. It is a geopolitical contest for who controls humanity's next frontier. And the stakes are higher than they might appear. So where has all the money gone? A 2021 audit from NASA's Office of Inspector General projected that the entire Artemis effort would cost $93 billion up to fiscal year 2025. The same report estimated the cost of operating the Space Launch System, Rocket and Orion spacecraft at $4.1 billion per launch for the first 4 missions. That number, $4.1 billion per launch, is worth letting sink in. For every single flight, NASA is spending roughly the same amount as some countries spend on their entire national space programs. And 2 years later, a Government Accountability Office report found that senior NASA officials themselves saw the Space Launch System as unsustainable at current cost levels. So why is it so expensive? The core of the problem goes back to how the rocket was designed. Development of the Space Launch System began in 2011 as a congressionally mandated replacement for the retiring Space Shuttle, and it incorporated a lot of legacy Space Shuttle hardware, including the same liquid hydrogen fuel systems that caused the hydrogen leaks that repeatedly delayed Artemis 2's launch. NASA was essentially building the future on top of 1970s technology. The delays followed accordingly. The program was years behind schedule before it even left the launch pad. Here is where the story takes a major turn, because NASA's strategy has fundamentally changed. In late March 2026, NASA Administrator Jared Isaacman announced ambitious long-range plans to spend $20 billion over the next 7 years to build a moon base near the lunar South Pole, featuring habitats, pressurized rovers, and nuclear power systems. At the same time, NASA cancelled plans for the Gateway, a proposed space station in lunar orbit that was supposed to serve as a midpoint between Earth and the Moon. Instead, components already being built for Gateway will be repurposed for the surface base itself. The orbital detour is gone. NASA is going straight for the Moon. The plan is structured in 3 phases. Phase 1 focuses on sending rovers, instruments and technology to the surface to test power, communications, navigation, and mobility tools. Phase 2 involves building semi-habitable areas for astronauts, with help from international partners, including JAXA of Japan. Phase 3 is the end state. Larger habitats and vehicles, contributions from the Italian and Canadian space agencies, and the transition from short visits to a permanent human presence on the Moon. The location of this base isn't random. The lunar South Pole is one of the most strategically important places in the solar system, and one of the most hostile. The South Pole region is essentially a volcanic desert, with temperature swings of hundreds of degrees, abrasive lunar dust, and a near-constant shower of cosmic radiation from the black sky above. But what makes this death trap so desirable is that it is home to reserves of frozen water, sitting in craters that have not seen sunlight in billions of years. That water changes everything. On the Moon, water ice can be split into hydrogen and oxygen. Hydrogen and oxygen are rocket fuel. A base near the South Pole could, in theory, manufacture its own propellant from local resources, making the Moon a fueling depot for deeper space exploration, rather than a destination that requires everything to be shipped from Earth at enormous cost. Several robotic missions under NASA's Commercial Lunar Payload Services program have already been scouting landing sites near the South Pole, testing resource utilization concepts, and performing lunar science to support the Artemis program. The groundwork for choosing a permanent base location is already being laid. One of the biggest changes to the program is NASA stepping back from building everything itself. The revised Artemis architecture envisions moving away from the government-owned space launch system in favor of competitive commercial rockets being developed by SpaceX, Blue Origin, and others. The idea is that competition drives down cost, and that private industry can move faster than a government procurement process. SpaceX's Starship and Blue Origin's New Glenn are both being developed as potential human landing systems to carry astronauts from lunar orbit down to the surface. NASA says nothing will move forward unless the landers are proven to safely land humans on the Moon. But the shift toward commercial hardware represents a fundamental change in how NASA does business. Looking beyond the first Moon landings, NASA intends to target crewed lunar surface landings every 6 months, with the potential to increase that cadence as capabilities mature. That's a completely different rhythm from Apollo, where each mission was a standalone event that took years to prepare. The long-term vision is an airport, not a one-off expedition. None of this is guaranteed. The program has a long history of optimistic timelines meeting hard reality. The schedules laid out by NASA's leadership are undeniably ambitious, especially when measured against recent delays. Artemis 2 was originally planned for 2024. It didn't launch until 2026. Even the hardware has raised questions. During the uncrewed Artemis 1 mission, Orion's heat shield showed unexpected damage on re-entry, forcing months of analysis before NASA could certify Artemis 2 for a human crew. Fixes are now being built into Artemis 3, adding yet another layer of complexity to an already demanding mission. And then there's the political dimension. Each new administration brings its own priorities. Funding rises and falls with shifting budgets. The $20 billion vision for a sustained lunar presence still depends on continued support. And history has shown how easily even the most ambitious space programs can be reshaped or quietly left behind. Because getting to the Moon is one challenge. Staying on course might be the harder one. With Artemis 2 now complete, NASA's focus turns immediately toward assembling Artemis 3 and preparing to return astronauts to the lunar surface. Artemis 4 and Artemis 5, both crewed surface landings, are currently scheduled for 2028. After Artemis 5, NASA plans to land astronauts on the Moon every 6 months as a permanent presence begins to take shape. This is the most ambitious space program any nation has attempted since the original Apollo era. It brings together government rockets, commercial landers, international partnerships, nuclear power systems, and a long-term construction effort on a world 240,000 miles away, one of the harshest environments known to science. As NASA said after Artemis 2's splashdown 53 years ago, humanity left the Moon. This time, the plan is to never give it up again. But the real question isn't just whether we can return, it's what happens when we finally stay.